So this exercise, the topic 2.2 question related to the thermal properties and the temperature. Everyone should participate. You will use a chat. The chat is open to answer the questions. So we'll begin with question 1. Question 1. Don't bother about answer being wrong. It's important that you all participate. So what could be the answer for question 1? A knife is being sharpened on a rotatory sharpening stone. A spark flies off and lands on the operator hand. The spark is very hot, a small, very hot, very small piece of a metal. The operator feels nothing. So what is the right answer for this? The correct answer for this one is B. Because look, it is a piece of a metal which falls on the hand of the operator. Metal, what shows about the piece of the metal? Metal is a good conductor. But we know all metals are good conductor, but the operator feels nothing. If the operator feels nothing, it means this piece of a metal or a spark is not carrying too much energy, or if it is not, or it is not stored, it does not store too much energy, or we can also say it has a low thermal capacity. That's why B will be the right answer. Four blocks made up of different material, each given the same quantity, which is having a greatest thermal capacity. The thermal capacity is inversely proportional to temperature change. If we have a small change in temperature, we'll have a higher thermal capacity. So which has the smallest change in temperature, 2 degree, the smallest change in temperature, so it will have the highest thermal capacity. So A will be the right answer for question 2. Question 3. A long thin bar of a copper is heated evenly. If we heat something evenly, what will happen? Substance expand on heating and contract on cooling. So what will happen? The size will increase, the dimensions will increase, and it will become longer. Next, we have question 4. So question 4, answer you can already see that D is the right answer. Why D is the right answer? If we have a block of ice is heated until it all melts, and a water that is produced is heated until it boils. What happened when ice is melting and the water is boiling? So whenever there is a change in state, there is no change in temperature. Temperature remain constant. Temperature remain constant when the substance changes the state. So if a solid is melting or a liquid is boiling, the temperature does not change. So that's why D was the right answer for this. Then the last question for today, question 5. So we have 1 kilogram of water and 1 kilogram of aluminium heated to same temperature and then allowed to cool. Why does aluminium cool more quickly than water? So why aluminium temperature change is greater, like quicker? Because they mentioned they are heated to the same temperature, but aluminium cool down faster. Like let's say we have equal amount of water, 1 kilogram of water is there, and 1 kilogram of aluminium. And the temperature, when we heat both of them initially, let's say this is at 50, this is also at 50. But when we cool down the temperature of a water, let's say in 2 minutes, it changes to 40 degrees. But in aluminium, the temperature in 2 minutes, it might changes to, let's say, 30 degrees. So what is the change in temperature for the water? The change in temperature of a water is only 10 degrees. And what is the change in temperature for the aluminium? It is 20 degrees. What is the relation between a thermal capacity or the specific heat capacity and temperature change? They are inverse. If we have a smaller change in temperature, it means it will have a higher thermal capacity. If we have a greater change in temperature, it will have a smaller thermal capacity. So it's about thermal capacity. So what this give an idea that because they mention aluminium cools more quickly, or there's a greater change in temperature for aluminium as compared to that of water. So it means aluminium temperature change is greater, so thermal capacity will be lower. So D will be the right answer here as well. Is it clear?